네, 네, 안녕하세요, 여러분. 디지털 시대 인공지능과 법 13주차 강의를 시작하도록 하겠습니다. 우리 13주차의 주제는 인공지능과 사법입니다. 우리가 이전 시간까지 헌법, 형법과 인공지능에 대해서 배웠었죠? 이제는 이제 사법에 대해서 보도록 합시다. 사법이라 그러면 이제 민법, 상법 같은 개인과 개인 간의 어떤 법률 관계를 다루는 법을 말합니다. 그래서 지난 시간에는 우리 인공지능과 형사법에 대해서 배웠죠. 그래서 이제 우리 여러분들이 이제 범죄자들의 재판하는 그런 형사법정을 떠올리시면 될 텐데요. 절차법적인 측면에서 인공지능 판사에 의한 알고리즘 재판 어떻게 생각하시나요? 뭐 그렇게부터 시작했죠. 그리고 또 실제법적인 측면에서 뭐 이렇게 범죄를 제형 법정주의라고 하는 것이 있었는데 거기에 따라서 이제 로봇 범죄 또는 로봇 경찰 뭐 이런 이야기들을 좀 했던 것 같아요. 근데 현실적으로 이게 영화에서는 이제 그런 게 문제가 많이 될 텐데 뭐 현실적으로는 이제 프라이버시라든지 감시의 문제, 그래서 개인정보 침해에 관한 어떤 범죄 이런 것들이 더 지금 현실적으로 문제가 된다라고 하면서 뭐 관련된 그런 영상들을 한번 봤던 것 같아요. 우리 이제 인공지능 법은 굉장히 좀 새롭게 형성돼가는 법이라서 많은 부분 좀 현행법이 못 따라가고 있는 측면도 많이 있거든요. 여러분 이제 뭐 그런 것들을 좀 앞으로 그래서 이제 법 제도를 좀 정비하고 또 거기에 맞게끔 이제 새롭게 구성해 나가는 디자인해 가는 이제 그런 작업이 필요할 것 같습니다. 자, 이번 시간에는 이제 인공지능과 사법에 대해서 볼 텐데 역시 개인과 개인 간의 생활 관계 아무래도 이제 민감 부분에 인공지능 법이라고 할 수 있겠죠. 그래서 이제 경제 분야에서 어떻게 인공지능을 우리가 활용하고 거기에서 법적 쟁점 뭐가 있을까? 아마 이제 마인드셋을 좀 해야 될 것 같은데요. 앞으로 이제 비즈니스를 할 때 적어도 인간과 인공지능이 서로 협업하는 뭐 그런 단계로 가야 되지 않을까 생각을 들고요. 특히 이제 우리 법률 분야에서 보면 리걸 테크라고 있어요. 이것이 이제 인공지능 기술을 어떤 법률에 뭐 입법, 행정, 사법에서 활용을 하는 이제 그런 것을 리걸 테크라고 하는데 여러분들이 이제 뭐 인공지능 변호사 뭐 이런 것들을 생각하면 될 것 같고 인공지능 판사나 뭐 인공지능 경찰 이런 것들은 이미 봤죠 우리가. 그리고 사법에서 인공지능 이슈라 그러면 예를 들어서 우리가 이제 알고리즘에 따라서 뭐 이렇게 계약을 체결하는 그런 것들이 있죠. 그리고 또 불법 행위와 관련한 어떤 책임 문제, 손해배상 문제 이런 것들도 이제 인공지능 기술로 우리가 좀 많이 활용할 수 있다는 점이고요. 그리고 이제 로봇의 책임, 예를 들어서 자율주행차 같은 경우에 운전할 때 사고가 났을 때 어떻게 책임을 질 거냐부터 시작해서 로봇이 관여하는 그런 책임들이 있죠. 또 저작권 같은 것도 있을 수 있고요, 그죠? 그리고 또 가장 마지막으로는 이제 사이보그에 대한 문제를 조금 검토를 하면서 과연 이제 우리가 자연인이라고 하는 것을 새롭게 정의해야 되지 않겠는가, 그죠? 뭐 이런 생각도 좀 하면서 시작해 보도록 하겠습니다. 자, 경제 분야에서 인공지능이라고 하면 이미 금융권에서는 굉장히 많은 이제 인공지능 기술들, 빅데이터라든지 이런 기술들이 활용이 되고 있어서 뭐 투자 뭐 타이밍을 고른다든지 종목을 고른다든지 할 때 이미 많은 사람들이 인공지능에 의존해서 투자를 하고 있습니다. 그리고 법률 등의 분야에서도 이미 알고리즘에 의한 서비스가 많이 제공이 되고 있고요. 그래서 검색할 때 저도 많이 활용을 하고 있습니다. 약한 인공지능이라고 할 수 있겠죠. 이미 그 로봇 어드바이저라든지 또는 로봇 변호사 등이 대표적인 거라고 할 수 있겠어요. 자, 여러분들이 이제 저는 이제 아마존이라든지 구글이 그런 기업 형태가 이제 플랫폼 기업이기도 하면서 빅데이터 기업이기도 하죠. 그런 데서는 이제 인공지능 기술을 많이 활용을 하고 있는데요. 여러분들이 이제 알고리즘이 들어가 있는 뭐 검색이라든지 그래서 내가 어떤 걸 샀을 때 그것과 연관돼서 뭐 추천하는 상품들 이런 것들 표시해 주기도 하고 또 상품 재고라든지 또는 유통에서도 보면 인공지능 기술이 활용이 되고 있어요. 예를 들어서 여러분들 아마존 고라고 아세요? 그런 것들이 있고요. 또 구글이라든지 페이스북에서 대표적으로 이런 빅데이터 기술을 활용해서 어, 그 비즈니스를 하고 있다라고 할 수 있는데요. 몇 가지 좀 보도록 할까요? 먼저 이 우리 창고에서 이 부분을 먼저 보도록 하죠. 이렇게 하면 되겠죠.
Meet Amazon's newest holiday workers, the Kiva robots. At this fulfillment center in Tracy, California, more than 3,000 of them cruise the warehouse floor, helping employees fill millions of orders.
The little orange robot goes out and picks the right pot of inventory and brings it back just at the right time for the person to pick the item out to go on that customer's shipment.
Before the Kiva robots, the workers used to walk the warehouse aisles picking up the items. But now they stay on these platforms, and the robots bring the shelves and the items directly to them. The 320-pound robots can lift up to 750 pounds. They have motion sensors to detect objects in their way and can travel between 3 and 4 miles per hour. Amazon says the robot's small footprint allows it to squeeze in 50% more inventory into this warehouse, which is the size of 59 football fields. They've also improved efficiency by 20%, so it only takes 15 minutes to fill some orders instead of 90. On Cyber Monday last year, Amazon customers ordered 426 items every second. Amazon expects that number to be bigger this Cyber Monday. The process at an Amazon fulfillment center starts when products arrive by the truckload. The items are sent up to one of the 4 floors where Kiva robots operate.
In this new generation fulfillment center, we have associates who are taking products off the carts and putting them onto the shelves that are moved by our Kiva robots.
A worker finds a space to stock the item on one of the moving shelves. It doesn't matter if there are paper towels next to board games, just as long as the robots know where to find it among the 21 million items. Then the robots wait to retrieve the item when someone places an order. From there, items are hand-picked and whisked away on miles of conveyor belts to be sorted, packed, and shipped. There's even a robot that folds the shipping boxes. While some may worry about robots taking jobs away from humans, Amazon insists that is not their intention.
You're going to see there's 4,000 people working in this building, even with all the automation that's in place here. That's because our focus on automation is about helping people do their jobs, not replacing people.
So far, 10 of the 50 Amazon fulfillment centers in the United States have integrated the Kiva robots. In Tracy, California, I'm Kara Suboy, CNET.com for CBS News.
Oops.
문제는 끊임없이 단순하고 효율성 높은 생산 기술로 대체하려고 하는 자기 속성을 갖고 있다는 거죠. 어떤 뛰어난 선각자가 최사회를 진단하는 것이 아니라 경제의 기본
논리입니다. Over and over again, we saw these examples of science fiction becoming
Oops. 잠깐만 멈춰야 될 것 같아요. 잠깐만요. 네. 네, 잘 보셨어요? 이게 조작이 너무 쉽지 않네요. 네, 이게 지금 와이파이가 속도를 잘 못 따라가서. 자, 지금 다시 두 번째 화면을 좀 보도록 할까요? 네, 잠시만요. 옵스. 넘어가 버렸네요. 네. 잠시만, 이것만 보도록 하죠. 네, 이것은 이제 아마존 고에 대한 이야기인데요. 네, 소리를 넣어드리고요. 예, 시작했습니다.
이미지 처리 기술.
자, 처음부터 다시.
안녕하십니까. 오늘 여기는 세계 최초의 무인 점포 아마존 고에 나와 있습니다. 아마존 고는 오픈한 이후에 많은 화제를 일으켰는데요. 아마존 고는 기다리는 줄, 계산대, 종업원 등 세 가지가 없는 점포입니다. 170제곱미터, 약 51평 규모의 소규모 매장에 오렌지 주스, 우유, 감자칩 등 기존 편의점에서 볼 수 있는 제품이 진열되어 있습니다. 여기까지는 일반 편의점과 다를 바 없습니다. 하지만 내부에 들어가 보면 완전히 다릅니다. 아마존 고의 핵심은 Just Walkout 이란 기술입니다. 매장 내 각 제품에는 센서나 칩을 부착하지 않습니다. 하지만 천장에 달린 100여 개에 달하는 센서가 실시간으로 손님과 제품을 추적하고 있습니다. 사진 태그에 사용되는 이미지 처리 기술도 사용됩니다. 아마존은 자율주행차에 사용되는 딥러닝 기술을 매장에 사용하고 있다고 밝혔습니다. 자율주행차 여러 대가 매장에 굴러가는 것 같은 효과를 보고 있는 것입니다. 아마존 고를 이용하려면 스마트폰에 앱을 내려받아야 합니다. 매장에 들어설 때 지하철 개찰구처럼 생긴 입구에 자동 체크인을 합니다. 원하는 물건을 진열대에서 집어들면 인공지능 센서가 자동으로 인식하고요. 물건을 선반에 내려놓으면 장바구니 목록에서 자동으로 삭제됩니다. 쇼핑을 마친 뒤 매장을 나오면 앱과 연결된 신용카드를 통해서 자동으로 계산되기 때문에 별도의 결제 과정 없이 걸어 나오면 됩니다. 아마존은 지난 2018년 1월 시애틀에서 처음 오픈한 이후 반응이 좋자 시카고, 샌프란시스코 등으로 매장을 확대했습니다. 오는 2021년까지 매장을 3,000개로 늘린다는 보도가 나왔는데요. 이렇게 되면 미 전역에서 아마존 고를 볼 수 있을 것으로 예상이 됩니다. 매장 내에서 물건 진열에서부터 운영에 이르기까지 기존 유통의 모습도 크게 바뀔 것으로 보입니다. AI 기술이 실제 생활에 깊게 파고들게 되고 AI를 체험할 수 있는 대표적 사례가 될 것입니다. 어떻게 보셨습니까? 이렇게 아마존 고는 단순히 무인 점포가 아니라 인공지능 기술에 기반을 둔 미래 매장이다라고 볼 수 있을 것 같습니다. 지금까지 시애틀에서 손재건 특파원이었습니다.
네, 여러분 잘 보셨어요? 네, 아마존에 대해서 했는데요. 구글에 대한 이야기가 이제 제프 딘의 영상이 있는데요. 모두를 위한 인공지능이라고 해서 이 영상이 좀 종합적으로 잘 정리된 것 같아서 여러분들하고 같이 한번 이 제프 딘의 영상을 보도록 하겠습니다. 한 16분 정도이고요. 그러면 같이 공유해 보도록 하겠습니다. 이게 아니고, 네, 이것부터 먼저 해야 되겠죠? 아직 이게 안 됐네요. 네, 이제 됐군요.
Hi, I'm Jeff Dean. I lead Google's artificial intelligence research team. I'd like to tell you first about Daniel De Leon. Daniel is a student at California Polytechnic University in the United States. Daniel's studying engineering, but he also has a real passion for music. Both his parents were musicians, and he grew up with music all around. Hi, I'm Jeff Dean. I lead Google's artificial intelligence research team. I'd like to tell you first about Daniel De Leon. Daniel is a student at California Polytechnic University in the United States. Daniel's studying engineering, but he also has a real passion for music. Both his parents were musicians, and he grew up with music all around the house. When he got to university, he really started to understand the science behind how sound waves combine and then are affected when we listen to the sounds in our eardrums. So Daniel was really interested in sound and in engineering. He went to a career fair where he met Daniel and John. Danielle and John are from the Monterey Bay Aquarium Research Institute. It studies different kinds of aquatic life and its behavior. So Daniel and John had an interesting problem, and they were talking to Daniel about it. And the problem related to how can we use artificial intelligence to detect whales. So Daniel and John had put microphones all around the seafloor, and they really were trying to identify where whales are. By understanding these endangered species, we can actually understand their motion, their behavior, and it's really problematic to track whales because they only communicate via sound, because light only penetrates a few hundred meters below the ocean surface. So let's listen to what whale sounds like. It's pretty distinctive. Oh, it's even more distinctive. So by listening to these sounds, we can actually figure out where whales are. But there's a problem. By putting microphones all around the seafloor, they've accumulated hundreds of thousands of hours of mostly boring audio. So how can we find out where the whales are in that audio? It would take tens of human lifetimes to listen to all that audio. So Daniel and Danielle combined together, and using the recordings that they collected, they actually set out to develop an automated approach to this, a new tool. So Daniel actually used a technique to teach a computer to listen for these kinds of sounds. And by listening to these sounds, using a tool to recognize patterns in the audio waveforms, he was able to achieve 98% accuracy in finding where whales were making noise in these hundreds of thousands of hours of audio recordings. And by doing that, they're now able to track these whales and understand their motion behavior, their patterns of swimming around in the ocean, and how they're migrating. And that enables us to understand these endangered species much better. So what was Daniel doing here? He was actually deploying a technique called artificial intelligence. By training a computer to learn to recognize these kinds of patterns using a piece of software that is open source software for machine learning called TensorFlow. So that story is only one use of artificial intelligence in the world. There's millions of potential uses of this technology. And Google has been looking at how can we make artificial intelligence available to everyone for many years. We've been doing research in this field, and we've been doing three things. We've been making our applications more useful by putting artificial intelligence into the product features that we all use every day. We've also been helping other people innovate and use artificial intelligence in their own work by open sourcing products like TensorFlow and developing cloud products that enable businesses and other organizations to put this to use in their own problems and organizations. And we've also been working on solving some of humanity's big challenges using artificial intelligence. So I'm going to tell you about each of these three areas in a few minutes. But first, I want to get everyone on the same page and describe what artificial intelligence really is. So artificial intelligence has been around since the very creation of computers. People have dreamed about making computers smart in the same way that people are smart. And so it's really the science of making things smart. And when artificial intelligence was first dreamed about, people imagined it more as we would tell computers how to be smart. We would tell them a bunch of rules about the world, and then they would be able to sort of use those rules to be smart about things. In more recent years, though, we've learned that the best way to make machines intelligent is to actually make them able to learn rather than telling them everything about the world. Instead, we're going to teach them to learn about the world by observing the world themselves or observing things on their own. So let's see how this works. There's two main phases to learning in a machine learning algorithm. The first is training. So we're going to expose a machine learning system to examples of what we want it to learn. And by doing that, let's say we want to train it to learn things from images, to be able to take in an image and tell you what is in that image. You know, it might be two categories like cat or dog here. It might be thousands of categories of things. But we're going to show it examples of things. We're going to say, that's a cat. There's a cat. That's a dog. Dog. Cat. Dog. And the computer is going to make some mistakes at first. It's going to say, that looks like a dog. And when it gets it wrong, it turns out through the training process, through basic mathematics, we can actually make little adjustments to the machine learning view of the world, the machine learning model's view of the world, to make it so that next time it sees that image or an image like it, it's more likely to give the correct answer than the wrong answer. So we continuously do this process of showing it an image, showing it an example. If it gets it wrong, making little adjustments to the model so that it's more likely to get it right next time. And the whole idea is so that then we can use it once we've trained the model. We want to be able to do what's called inference, where we show it a completely new thing that it's never seen before and have it make the correct answer, give the correct answer. So here we're going to show it a new image that it's never seen before, and it needs to say cat or dog. And that's really the essence of machine learning. Show it lots of examples, make it behave well on those examples so that it can generalize to these new kinds of examples, and then use that in all kinds of powerful ways. So to give you an example of how much progress has been made in recent years, let's look at the field of computer vision. So Stanford University runs a contest every year called the ImageNet Challenge. And in 2011, before contestants were using a particular kind of machine learning, the error rate for the winner in 2011 was 26% errors on this task. And we know that humans have about a 5% error rate on this task. It's actually pretty hard. You're given an image, and you have to give one of 1,000 different categories for that image, including 40 breeds of dogs. So it's actually hard enough that humans can't do it perfectly. So there's been a lot of progress in using machine learning over the last few years. And in 2016, the winning entry got 3% error rate. This is a really big deal. We've basically gone from computers not being able to see very well at all to being able to see really well. And if you think back to the time in evolution when animals evolved eyes and they could suddenly start seeing things, that's where we are with computers today. So being able to see just opens up an incredible number of possibilities, some of which I'll talk about today. And we've made similar progress in other fields of machine learning, including speech recognition and language understanding as well. Okay, so let's look at making apps more useful with artificial intelligence. So we've been using these basic capabilities in many ways throughout our products. So for example, if you search for dogs in your photo album, we can actually understand what images of yours actually contain dogs and show you those dogs right away. That's one example. We can also make the world around you able to be searched visually. So there's an application called Google Lens where you can hold up the camera viewfinder and show it different objects, and it will tell you about those objects. This is really helpful for me if I'm wandering around Seoul and I see this beautiful building and I want to know more about it. I can search it visually. I just put it in my viewfinder. Or if I'm hiking in the hills and I see these beautiful fir kind of plants and I don't know much about them, or this particular kind of dog, right? So it can really make the world visually accessible to everyone. Translate is also a really handy application if you're traveling, particularly if, like when I'm traveling in Korea, the character set itself is unfamiliar to me. So this is an application where you hold up the camera viewfinder and you can it actually learns to recognize where text is in the image and then to translate it and then to superimpose that on the viewfinder image that I'm seeing so it looks like the text is written in my language even though I'm in an unfamiliar environment. Another example is being able to reply quickly to emails that you received on your mobile phone, We all know it's a real big pain to actually type on our mobile phones. And so by being able to reply to emails quickly, one of the things we can do is take an email you've received and understand the text of that email to the point that we can actually suggest a few replies. So if a friend of ours is asking, you know, hey, can you come over for dinner at 6 p.m. tomorrow? It can suggest, sure, I'd love to, or no, I'm sorry, I can't make it. And then you can just click one of those rather than having to type a reply. So helping others innovate is another thing we care deeply about in bringing AI to everyone. So we've been providing developer tools like TensorFlow. TensorFlow is an open source package that people can use for machine learning, and they're using it for all kinds of things. The example of Daniel and the Monterey Aquarium is but one example where people have used this tool to do something powerful with machine learning. We've also been making our artificial intelligence interfaces available through our cloud products. So we have interfaces where you can give an image to a cloud interface, and it will give you back information about that image. It will give you back all the text that it could find in the image in textual form. It will tell you what kind of image that is. And we've also been investing in developing customized hardware that can run these kinds of algorithms efficiently and making that available through our cloud as well. For example, Timon is a Korean company that accepts products on its website. And one of the things it wants to be able to do is to read all the text on the product images that its customers upload so that they can understand what text there is and make sure that there's, for example, no claims that the product is making on the product label that are inconsistent with what the product actually is. And by automating that, they can avoid having humans look at every single product image that has been uploaded. But solving for humanity's big challenges, I think, is one of the really most interesting ways that AI will help us. So let's look at the problem of healthcare. Healthcare has seen tremendous potential in the use of machine learning to really improve the kinds of care we give to people and also the basic life sciences that underlies the development of new kinds of treatments. So our group has been looking at the use of machine learning for detecting eye disease. There's a disease called diabetic retinopathy, which is the fastest growing cause of blindness in the world. And there's about 400 million people at risk for this around the world, scattered around the world. And the normal way that you get assessed for this is once a year you should go in and have an ophthalmologist take a picture of the back of your eye with one of those special eye cameras. And then an ophthalmologist will look at that image and will assess, you know, does this person show signs of diabetic retinopathy? And this is really important because if you detect early symptoms, you can actually treat the disease and not suffer any vision loss. But if you don't detect it early enough, people will suffer vision loss. And in many parts of the world, there just aren't enough ophthalmologists to actually interpret these eye images to make sure that everyone gets the proper screening. So it turns out that this is also a problem for computer vision, for artificial intelligence. We can actually automate the process of looking at these eye images by collecting a very carefully curated data set of eye images with human labels by human ophthalmologists saying, this is diabetic retinopathy, this is not, in the same way we did cats or dogs. And we can actually do quite a good job. We can also predict different medical events with artificial intelligence. And so here you can imagine a patient's medical record and as a sequence of events, and we can use artificial intelligence to predict what's going to happen next, which is essentially what doctors are trying to do. They're trying to predict the future for a patient and know how best to treat them. Other examples include protecting endangered birds using computer vision. These are examples that other people outside of Google using TensorFlow have developed. In Tanzania, making food safe, detecting diseases on the cassava plant, which is the main source of carbohydrates for 500 million people around the world, and telling farmers not only what disease it is, but also how to treat it on their plants. We've also made new scientific discoveries. So one of our researchers working with Harvard astrophysicists was able to find new planets in a large database of data collected by the Kepler Sky Survey telescope by looking for these micro variations in brightness of stars as a planet orbiting a star goes in front of that star. We want to bring AI to everyone, and if you're excited about these kinds of techniques, we've open sourced and developed some curriculum to teach people about AI and how to apply it to new problems at ai.google/education. We think that's a really good way for people to get started and to learn about how to use these techniques for all the different things that they can be used for. So our mission is to make the benefits of AI available to everyone in our products, through releasing things that other developers can use, and also in working with our own researchers and with other researchers around the world to really solve humanity's big challenges. With that, thank you very much.